Welcome you all. Today we will discuss the different synthesis of the CNS active drugs, mostly from the local anesthetic drugs, in the subject of medicinal chemistry, second to the third year B pharmacy students. Myself, Dr. P.B. Mohite, Professor and Head Department of Pharmaceutical Chemistry, will going to present a small topic, that is synthesis of drugs from the local anesthetics. Now let us have the look on all these synthesis. Firstly, see the synthesis of mepivacaine. Mepivacaine is one of the local anesthetic agent which comes from the category of the amides. Now this synthesis is carried out in the 3 steps. Now let us see the first step of this synthesis. Now step first is mostly related with, that is the benzylation type of the reaction. In this reaction, 2,6-dimethyl aniline react with pyridine 2-carbonyl chloride. Here there is a removal of HCl and it gets converted to the amide linkage. The name for this compound is N2,6-dimethyl phenyl pyridine 2-carboxamide. This compound is formed in the first step. This first step compound undergo reduction in the step second in presence of ranitidine. When it undergo reduction, it is converted to the piperidine ring. This is the piperidine ring which undergo reduction. So here double bonds are reduced, so it gets converted to the piperidine ring. In step 3, in which the actual mepivacaine is synthesized, this piperidine group undergo N-methylation. At this amino group, there is addition of the N-methyl group. So it gets converted to the N-methyl derivative. This N-methyl derivative is nothing but the final structure of this mepivacaine. So we have studied that. We will have the small review on this synthesis. That is the step first, which is a benzylation type of the reaction. Step second, which is a reduction reaction, and step third, which is a N-methylation type of the reaction. So here we have discussed the 3 steps for the synthesis of the mepivacaine. Within short period of time, we can remember also this reaction, that is the benzylation reaction. Then second one, that is the reduction reaction, and third one, that is the N-methylation type of the reaction. Now this mepivacaine, which is used as a local anesthetic, the IUPAC name for this compound is N2,6-dimethyl phenyl 1-methyl piperidine 2-carboxamide. So it comes from the category of the amides. So this is all about the synthesis of mepivacaine. Now let us see the second synthesis from the same category, but here it comes under the category of the esters. First example we have studied, that is from the amides. Now this example is from the esters. Procaine is a well-known ester derivative which acts as a, again, local anesthetics. This synthesis is also carried out in the 3 steps. First step, that is reaction of 4-nitrobenzoic acid with thionyl chloride. So it gets converted to the 4-nitrobenzoyl chloride. So COH group is converted to the COCl group. Remaining structure is same. So there is no difference in the structure of the parent compound, only change in the carboxylic acid group. Carboxylic acid group is converted into chloride group. In step second, 4-nitrobenzoyl chloride reacted with dimethyl amino ethanol. Now see here it is differentiated by using the colors. The OH group reacts with the Cl. So here there is a removal of the HCl. When there is a removal of HCl, there is a formation of the ester. So it is a simple reaction, that is the benzoyl chloride reacts with the ethanol. So it leads to the formation of the ester linkage. Now that is not the ultimate structure of the procaine. In third step, there is a again reduction reaction in presence of the ranitidine. So nitro group of intermediate compound is converted to the amino group, and that is the final structure of the procaine molecule. Now this procaine is synthesized from 4-nitrobenzoic acid within 3 steps. Again, let us have the overlook on this synthesis, that is the step first, in which there is a conversion of COOH group to the COCl group. In step second, there is a formation of the ester group, so it is called as a esterification type of the reaction. And step third, that is a reduction reaction. So again, procaine synthesis is carried out in the 3 steps. Now IUPAC name for this compound is 2-dimethyl amino ethyl 4-amino benzoate, which is also used as a local anesthetic agent. So again, within a short steps, that is step 1, step 2 and step 3, we can synthesize procaine by using 4-nitrobenzoic acid. Now let us have another synthesis, that is the synthesis of the diazepam. Now this diazepam is used as a sedative, hypnotics, as well as the anticonvulsant, as well as the anti-Parkinson drug. Now this diazepam synthesis is also carried out in the 3 steps. Now first step is called as the reaction of 5-chloro-2-aminobenzophenone. Now see here, this is first carbon atom, first, second, third, fourth, fifth and sixth. So at second position there is a amino group and fifth position there is a chloro group. So name for the compound is 5-chloro-2-aminobenzophenone. This 5-chloro-2-aminobenzophenone is allowed to react with glycine ethyl ether. See here, NH2 CH2 COH, this is the structure of glycine. It reacts with the ethyl group, so it is called as the glycine ethyl ether. This glycine ethyl ether, when reacts with carbonyl group here, when it reacts with the amino group, there is a removal of ethanol molecule along with the water molecule, so it gets converted to the NHCO NH2. That is the step first, that is by removal of ethanol molecule it gets converted to this NHCO NH2. That is the step first. In step second, that is called as a cyclization, which is carried out in presence of the pyridine. So pyridine is mostly used for the cyclization of the reaction. In this reaction, this open chain structure is converted into 7-membered structure. In this 7-membered structure, if we see the nomenclature, this nitrogen atom gets the first position, then ketone group second, then CH2 third, then this fourth, then fifth, then this one sixth, and this one is the 7th position. So 7-membered benz diazepine nucleus is formed. The name for this is 1,4-benzodiazepine 2-one. For this nucleus, that is the benzodiazepine nucleus is formed, which contains 7-chloro group. Now this cyclized product in step third undergo N-methylation reaction in presence of dimethyl sulfate. When it undergo N-methylation reaction in presence of dimethyl sulfate, there is attachment of methyl group to the first position amino group. So it gets converted to the N-methyl group. So there is a synthesis of this compound that is called as the diazepam. Diazepam is a very simple structure to remember. That is benzodiazepine nucleus is at the center, that is called as the ring B. To this benzene ring is attached, that is called as the ring A, and at fifth position there is another phenyl group, that is fifth position is substituted with the phenyl group. So that is the basic structure of the diazepam, which is the derivative of benzodiazepine. The IUPAC name of this compound, if we see here, at 7th position there is the presence of chloro group, at first position there is a methyl group, so 7-chloro-1-methyl, at fifth position phenyl group, then 1,3-dihydro, between the 1 and 3rd position dihydro group is there, then 1,4-benzodiazepine, at second position ketone group is there, so 1,4-benzodiazepine 2-one. This compound is used as the sedative, hypnotics, as well as the anticonvulsant. This is one of the simplest way to synthesize this compound. So what we have studied? We have studied that in step first, there is a reaction of benzophenone with glycine ether, which lead to the formation of the amides. These amides undergo cyclization in presence of pyridine. It forms the cyclic structure, that is the benzodiazepines, and in step third, benzodiazepines undergo N-methylation, and N-methylation lead to the formation of the final structure of the benzodiazepine. So in this topic, that is the synthesis of drug from the medicinal chemistry, we have studied the synthesis of procaine, synthesis of mepivacaine, and synthesis of the diazepam. These are the very simplest route for the synthesis of the drug. If you study